data similar to real data. That is the important concept. It does not create the real data. So it creates the real data which is very closer to real data. So the word generative tells it is a creates. Adversarial means nothing but conflict or oppositions of the two networks. So here two networks are available. One is the generator, another one is a discriminator. So networks is nothing but a neural networks. So GANs are deep neural network architecture comprised of two neural networks competing one against the another. That is why it is called as the adversarial network. So this is the image representation of the diagrammatic representation of the image generation with generative adversarial networks, that is GAN. So in this case there are two main persons involved in this GAN network. One is the generator, another one is the discriminator. In this picture it shows a human being, but normally generator is one type of neural network, discriminator is another type of neural network. So what is the function of the generator means it creates the fake images, whereas the discriminator classify the generated images as well as compared with the real image. Which one is the real and the fake? This is the another representation of the GAN model. So random noise, the generator input is a random noise, then discriminator compare the generated data with the real data. Finally, it classifies the real or fake. So these are the components of GAN. One is the generator, another one is a discriminator. So for generator, we are giving a random noise. It generates the fake images. Then the real images is also given to the discriminator. By comparing these two, the discriminator classifies real and fake. So this is the major things. So how GAN works? By using the adversarial process. Adversarial process is competing with each other. That means the two networks working opposite. The generator generating the images, the discriminator discriminate the images between real and fake. So adversarial process, generator creates the data, discriminator evaluates the data. The generator creates fake data from random noise. The discriminator evaluates the data to distinguish between real and fake. Though in feedback loop, both networks improve their performance. So by using the feedback, that is back propagations, the both networks are, that is discriminator and generator, to improve the performance by tuning the error. Then GAN components, already we discussed, there are two components, generator and the discriminator. Generators take data from random noise, learns to create a data distinguishable from real data. Discriminator evaluates the data authenticity, learns to distinguish between real and fake data. So this is the another easy representation of the discriminator model and generative model. So in the discriminator, discriminate the technique. What is the discriminative technique in the discriminative model means? So it has to classify the given input whether it is a dog or not. In the generative model, it creates the dog images. So the discriminated model, it consists of two inputs. One is the real images coming from the training set, another one is the fake images from the generator. Then it is a binary class. It classifies the data into a binary form, that is either 0 or 1, binary classifications. In this, the binary classification and sigmoid function is used for this discriminator model. So this is the combination of both generator and the discriminator model. So for generator model, we are only giving the random noise, that is from the distributions. Then it creates the fake images, it looks real, that is the important point. So the discriminator discriminate the generated images with real images. But the thing is, the generated may make a full the discriminator. That is the beauty behind in this concept. So the discriminator is difficult to find. This one is a real or fake. That time the discriminator do the best one. So the generators normally the CNN network, and then tan H function is used for error calculations and all. So discriminator frees the weights for D during training. That is how the tuning is taking place by using the bias and the weights. So this is the overall architecture of the GAN model. So generated, we are giving the noise as well as the some latent space. It generated the fake samples. For discriminator, the generated fake samples as well as the real samples given to the discriminator. The discriminator discriminate the uh, images, which one is the real, which one is the fake. If there is any difference in the generated images and the real images, means again the fine tuning is taking place for both generated and the discriminator. So the generator receives random noise and output fake data. The discriminator receives both real and fake data and outputs probability of authenticity. Already we discussed definitions and then two classes of models in machine learning. So discriminative model and then function. It is a distinguish between the classes such as identify whether the image is a cat or dog. So this is the proper definition for generative model. Given some standard random distribution, a generative model generates new data samples that resemble the data, a training data. The model captures the underlying distributions of the training data and can generate the new instance that are similar but not identical to the original data. So this is the diagrammatic representation of this definition. So here the generated G, which consists of neural networks, that is the input layer, hidden layers and the output layer. There is a distribution D, that is a real collection of the real images, that is close as possible D dash. So it has to find the D dash value. So here Z is nothing but the noise. So the noise is given to the generator. So the generating the images based on the Z, that is approximately equal to D dash. D dash is a D as close as possible to D dash. That is the main concept. So this is the architecture. This is simple example for the GAN architecture. This one is MNIST fashion data set. In this MNIST data set, one sample, that is real sample t-shirt, whereas in the generated model, so the random noise given to the generated model, it consists of 100 input layers and then 28 cross 28 nodes for displaying the images. So there are hidden 128 ReLU nodes. So ReLU functions is used to remove the negative values. Then the discriminator finds the output, whether the image is real or fake. How the learning mechanism is going on, generated as well as the discriminator. Here the generator generating the artificial intelligence, nothing but the generated images. The label is equal to 0. Then it is given to the discriminator. Also the real instances, which is the labeled by 1. So in this case, this simple human handwriting digits, that is 28 cross 28 images, input images. So it classify fake and real. So if it is a fake means 0, real means 1. So training the generator. So the generator has to generate the artificial intelligence, that is y is equal to 1. Then only the discriminator can find too difficult which one is the fake or real. So the training steps of the GAN: training the discriminator with the real and fake data, training generator to fool the discriminator. That is the main point. The generator to fool the discriminator. Train the discriminator with the real data labeled as real and the fake data labeled as fake. So that the discriminator has to do the labeled correctly. If it is a real means real, fake means fake. Train the generator to produce the data that the discriminator will classify as real. Then loss functions. So there are binary cross entropy between the real and fake labels and the discriminator's output. So here we are using the entropy binary cross entropy functions. So if we are if you are going to implement any GAN model bits, we can use MNIST dataset. And what are the tools is needed for implementing the model means TensorFlow, Keras and NumPy matplotlib. So this is the code for build generator. So already I told generated is nothing but a neural network. So for defining the neural network, this is a code. Define build generator latent dimension. In this we are using the sequential model. So that TensorFlow keras sequential model dot add. We are just adding the layers, that is dense 128 input dimensions equal to latent dimension, and then activation function is ReLU. So ReLU, the function of the ReLU is to remove the negative values. Then the hidden layers, the activation function is sigmoid. This is, it gives the output between 0 to 1. Then final the images is reshaped. That is, all the images should be 28 cross 28. Dense layers with ReLU and sigmoid activation, reshape layer to format the output as 28 cross 28 images. This is similar to generated, but this is on the build discriminator values. So in this case, the input layer, that is a flattened, the flattened layer to convert the input image into 1D array. The previous case, the output of the build generator is, it gives the images. That images is given to the discriminator by using the flatten function. The flatten functions is convert the input image into 1D array. Dense layers with the ReLU and sigmoid activation for binary classification. This is the code for training the loop. So in this case, the noise is equal to numpy.random.normal for creating the random noise. For generated images is equal to generated.predict by using the noise definition. Then index equal to np.random, random index is equal to extra 0, extract, shape of 0, batch size. So real images, we are given to the real images to train the data. So here create the labels for both real data, images and then fake images. So this is the code for training the discriminator. So here the 0.5 is equal to optimal value, then only the discriminator fooled by the generator. So this is the main thing. So this is the code for train the generator. Again, finally we print the output here. Then application of GAN's image generation and enhancement, that is creating realistic images from noise. Example, deep art style GAN. Then data augmentation. Augmentation in the sense enhancing the training data set by generating additional samples. Super resolution, enhancing the image resolution by using SR GAN. Medical imaging and drug discovery in medical field. So this is the example for video to text conversion by using the LSTM model. That is, by using the CNN LSTM, the video is converted into text like a man is talking. So this is the another example for text to video to text. So input video, then CNN for feature extraction, the encoder with by LSTM. So here by in the sense if we are using two LSTM, then decode the value. Again it gives the sentence, a person is playing guitar. Then challenges and future direction. The training is instability. That means it takes more time to train the discriminator and the generator. Then mode collapse. So mode collapse is nothing but one time the generator generating the same images for further. So this is the mode collapse. So this is one of the research issues or challenges in this GAN model. Then evaluation metrics is needed. Then future research areas and potential improvements is needed. That is, I am going to recap the topic again. So this is a GAN model. There are two blocks. One is the generator, another one is the discriminator. The generator, the neural network trying to create the pictures of cats that look real, not a real, it looks real. So discriminator, already it knows the thousands of real world images labeled cat, and it compare the generated images with the real images, and it classify which one is a real, which one is a fake. The art critic, a neural network examine cat pictures to determine if they are real or fake. Already we have seen this. This is the thing behind in the GAN model. So in the first attempt, the generator just gives some scribbling or line for making the cat. So that time the discriminator easily identified this is not a cat. So after the many attempts, it looks like a cat, but it is not a real cat, just outline of the cat generated by the generator. In this case also the discriminator find out this is not a cat. So even more attempts later it will tune to generate the cat looks like a real. In that case the discriminator identify this one is a real. So this is the basic thing behind in the GAN model. So there are two components, generated and the